Flaps are just one.
Alright, so discrete and continuous functions are the two types of
Miss Asher,
Yes.
can you please send Connor Freeman to Miss Hayes' office?
Yes.
Thank
Miss Hayes.
Who is that?
It's by the lunchroom. If you go up 2 halls and take a left, it'll be at the intersection on your right. I don't know. I don't know. I don't know any more than you know. I know nothing. Alright, so discrete functions are functions that measure something you count, like money, or how many baseballs you hit as home runs. They are a specific kind of graph. Continuous functions are things like time, or things that go over, like keep going forever and ever and ever. Discrete functions, it's a function that the graph consists of distinct points. So the points are not connected. They're just points on a graph. So if we connected it, that means that would mean that for every x value you could plug in, including any decimals, you would get a y value. This means that you plug in specific x values and get specific y values. Questions so far? Fantastic. Please open the Flappy. So for the first one, we're going to plug in these specific x values, and we're going to get y values and identify the range. So you have x, we have y equals 2x minus 1. That's where we're going to plug it in. And then we have y. So the middle column is going to be our process column. The x is what we're plugging in. -1, 0, 1, 2, 3. We're going to plug it in here, and we're going to see what we get for y. Does everybody understand?
Yeah.
So to start with, we're going to plug in -1. You do 2 times -1 minus 1. So what's 2 times -1?
-2.
And what's -2 minus 1?
-1.
You were so close there, baby. So close. Alright, now let's plug in 0. You have 2 times 0 minus 1. What's 2 times 0?
0.
And what's 0 minus 1?
Negative.
I need us to sound a little more confident on these answers. Yes. Alright, now let's plug in 1. What is 2 times 1? Minus 1 is?
1.
Oh my gosh.
1.
Okay, we're gonna get the next one, okay? Are y'all ready? We're gonna get the next one. What is 2 times 2?
4.
What's 4 minus 1?
3.
Oh my gosh, take a point. Alright, let's plug in our last x value.
6 minus 1 is 5.
Are we sure?
Yes.
Fantastic. Now, which values are the range?
And y.
These guys are the range. Yes, let's plot our points in graph. So we have to plot -1, -3. So we go left 1, down 1, 2, 3, put a dot.
Do you have to label it?
I have a question. Could you have just started at -1 and go down 2 and then over down 2?
Not yet. And you wouldn't go down, and you don't go over anywhere because we're not cows.
I mean 1. I mean 2 up.
Yes, but we're learning how to plug in because it's wanting specific ones. Alright, 0, -1, you would go straight down 1. 1, 1, you would go right 1, up 1. 2, 3, you would go right 2, up 1, 2, 3. And 3, 5, you go right 3, up 1, 2, 3, 4, 5. Do not connect your dots because it is a discrete function. It specifically says to plug in those x values and get out those y values, so you don't connect your dots. Does anybody have any questions? Do you think you could do the next one without me?
Yes.
Good job.
Can we do it? Why?
You don't have to make that full table if you feel confident, but if you want to, you can. Are we plugging in different x values this time?
Yes.
Look at y'all paying attention. Okay, let's not lie.
Wait. I also lied.
You just did.
That's a lie. Ow. I mean, no. Never mind. Doesn't matter.
Hello, pumpkin.
Do you think villains thing, or can you just like do the work and then the dance?
Do your work and just do it.
Okay, so let's go. Oh, I get it wrong. Is it a negative?
Did anybody get it right?
What was it? You didn't let me. Yeah.
You're right. I completely hindered you from finishing. So the reason it's 6 is because it's a negative 2, which is a positive 2, and 2 plus 4 is 6. A negative 1 is a positive 1, so 1 plus 4 is 5. 0 is 0, so 0 plus 4 is 4. Negative 1 plus 4 is 3. Negative 2 plus 4 is 2. Yes.
I'm an exact. Yeah, mine's an exact.
Like, it goes upside, like,
Yeah, mine
Right.
goes 2, 3, 4, 5, 6.
Flip it around.
Is it okay? Like,
No, it's not. It has to be like this. I just explained what happened. Because it's a negative 2 that turns it into a positive 2.
It's a negative times a negative is a positive.
Alright, so it's crazy that I explain things. Alright, now let's plot our points. You go left 2, up 1, 2, 3, 4, 5, 6. Left 1, up 1, 2, 3, 4, 5. 0, 4, 1, 3, 2, 2. Can I connect those dots? No, because it's discrete, and it gives you specific points with specific output. It doesn't say to plug in 0.5. Does everybody understand? Do you need a moment to fix it and graph it?
My dad had some of this. Oh, I think
Yeah.
my brother. I'm pretty sure. They're like customers.
No, they're not. They're moccasins.
My brother.
If it tells you to plug in specific numbers and get specific outputs.
I remember.
nah, it's not under, yeah, it's not under.
Like, then it's not.
Yep. Alright, so now let's look at the bottom, and let's identify why these situations are discrete. So let's talk about the first one. This is the number of movie tickets purchased, and then the cost. Why do you think that would be discrete? Connor?
Because they don't, all the ticket prices are the same.
No.
They don't connect the dots.
Right, why?
Well, maybe they don't like each other.
No, that's not an answer.
I know.
Because there's not a specific. It doesn't go up on the same.
Because you can't do like 8.50. We learned like something like that. We learned it in like literature. It's like we can't connect 850 to like a whole Yeah, it's something.
You're close.
Yeah, it's something like that. Like, it's like, yeah, it has to be a whole number to graph it.
Ish.
Something like, but it's like,
Ish.
if something's like a half of a pie, you can't put a half of a pie up there because you can't.
You can't get half of a movie ticket, so you can't connect the dots. Because if you connected these dots, you would be plugging in everything. If I connected these right here, I'd be plugging in every single number. But here, I can't have half a movie ticket. Take a point. Specifically Gryffindor. Specifically Gryffindor gets that point. Not everybody.
Okay, so look, you said you can't have half of a movie ticket. What if it's something like a pie? You can have half of a pie, so
Right, that's a different thing.
so that's not
Right.
okay. All right, I'm just gonna learn this because I think I understand.
Alright, so again, discrete means that you have specific points. It means that you have a specific input and you get a specific output. You can't have half of something. You can't have half of a movie ticket. You can't have half of a ticket to... What do y'all do?
Ice skate.
Okay, you can't have half a ticket to ice skate. You can't have half a ticket to Six Flags. You have to purchase the whole thing, and that makes it discrete. So it's things... Please sit up. Please sit up. You can't have half of something, so it's counting things. Like if we had marbles and we were dropping them into a bucket, can I have half of a marble?
No.
No, so that's discrete. Like what we wrote on the front. It's crazy, again, that I'm explaining this as we go. Alright, points during a game of laser tag. Has anybody played laser tag? Great. So when you hit a target, do you have to actually hit a target to get a point?
What do you mean? The low laser hits the low buzzer.
At the one fellow, just kind of like something.
Or you hit a player.
Well, you don't. Like the low laser hits the low buzzer and goes.
Right, but you can't hit half of a buzzer, can you?
That doesn't make sense.
Maybe.
Right, so you can't hit half of a target. If you hit the target, you get the point. So that's why this is discrete. You can't hit half of a target.
Oh, I.
Are we ready for continuous?
Yes.
Fantastic. So a continuous function has a graph that is connected. You do connect the dots for this one. Isn't it magic?
Yes.
Are we ready? Open your Flappy. So this one says graph the function with the domain where x is greater than or equal to 0. So what x values are we going to plug in this time?
1, 0, 1, 2, 3, 4, and 0 and above.
0 and above. Could I plug in a half?
No.
Yes, because that's above 0. Could I plug in 1 1/2?
Yes.
Could I plug in 2 1/2?
Pick your own number.
So we're going to do 0, 1, 2, 3.
Is that what it's saying?
Any numbers greater than or equal to 0.
Oh, then we can do it.
I know.
So we have to have 4.
Okay, never mind.
Alright, so then you're going to say 2 times 0 minus 1. 2 times 1 minus 1. 2 times 2 minus 1. 2 times 3 minus 1. Does it help to have the process column?
Yes.
Cool. Alright, what is 2 times 0? 0. What's 0 minus 1? What's 2 times 1?
2.
What's 2 minus 1?
1.
What's 2 times 2?
4.
What's 4 minus 1?
3.
What's 2 times 3?
6.
What's 6 minus 5? 1.
5.
Thank you. Hey, and we were actually on at that time. Take a point, children. Alright, now we're going to graph. So we're going to plot 0, negative 1, 1, 1, 2, 3, 3, 5. And are we going to connect those?
Yes.
Now, are we going to connect for x being less than 0?
Wait, what?
No.
We cannot draw a line past this point because it says that our domain is all x numbers greater than or equal to 0. Now, it tells us to identify the range. What are our y values?
Negative 1, 1, 3,
3 and 5.
Could it also be 0?
yes,
What about 1.5?
yep,
What about 2.5?
yep,
Is it any number greater than a certain number?
0.
0.
Yes.
What? It said right
It's
there.
not 0.
It's not. It said
Not for your range. What are the range values greater than?
negative 1.
Negative 1. Take a point. So it's y is greater than or equal to negative 1. Now, I would like you to please do the same thing on the next one.
Yes, ma'am.
We're almost done, and then you can do your study guide. Or we can check our study guide.
I love it.
No. No. Why do y'all think it's okay to look this is at your teacher?
Weird.
I was with Nick yesterday.
That's good.
Called it great.
That's good.
Okay, above 1, so it has to. Wait, so can you use 1? It's how many numbers do we have? Just do 3?
Do 4.
No, you can use any number. 1
Oh,
or 3. Greater than or equal to.
hey, man,
I think I did it right.
Oh, negative.
With the y, the y, all you do is negative right there equals to
Negative numbers negative x. Negative x.
I understand. 2 plus 4 equals 1.
There will be a negative 4. So 3 plus 4 is
That's 4. Because it's on the
right. 5, 6, 7, 8. You have it all right. Yes. No, it can't be 0.
Hold on.
You can't have 0.
Are we ready?
Yes.
Okay. All right. Watch your negatives.
negatives.
No, you're not.
It's
You're lost.
it's 1.
Oh,
We don't have to know how much time it is.
you're so funny.
Wait, it's 3. You know, I drew my arrow the wrong way.
how is our life lifting such a mistake? So,
Oh, you said we do her
Okay,
after
it's
that?
3, 2, 1, 0.
Okay.
oh, you were?
I'm so smart. Why am I so smart? I'm smart.
Y'all get 3, 2, 1, 0.
Yeah.
Why, Mark? What happened?
0, negative 1.
I used to get
Does it still look like ours?
Did you drop your negative?
Good.
Don't do that.
Good.
That changes the whole problem, doesn't it? Alright, so then 1, 3, you would go right 1, up 3. 2, 2, right 2, up 2. 3, 1, right 3. What is so funny about that? 4, 0 is right here. Now, can I extend my line to the
No,
left?
ma'am, you cannot.
No, I extend it this way. So what is my range, Ashlyn?
Y is less than or equal to 3.
Fantastic. Take a point. Although you also get a point. And if you got the table right, take a point.
I want to get there. You
You get
go.
points for everybody. That's right.
No,
I use
like 1 point. What numbers did you use?
I use 2, 3, 4, and 5.
As long as it's both not below.
Did you get 2, 1, 0, negative 1?
I got 2, 1, 0, negative. Yes.
So what I just said? Okay. Alright, so let's explain. Mark, are you better now? Are you sure? Okay, do I need to leave this? Are you good? Okay, go see. Alright, so let's talk about why these are continuous. Read this situation and tell me why it's continuous. Honor.
Because you can, it can be half the temperature, like 83.5.
Kind of. Avery.
It goes down by 3.
No.
No, it doesn't. No, it doesn't. It does.
Oh, it'll keep on going.
I skipped 79, that's why.
That's not it.
It's always gonna go down. Isn't it?
That's not necessarily it.
I was-
Wait, you can have half, you
Oh,
can have half an hour, or half a minute,
You can.
half a second.
Is that what you were going to say?
No, you just wait.
What were you going to say?
Me?
Yeah.
Like the time keep like time can continue going.
Time does continue going, and you can have half an hour. Good, both of you get a point. Time is continuous.
I said it's not gonna stop. That's what I said.
You were talking about the temperature.
No, I said that it's never. I meant like.
You said that it's never going to stop, and that's, I don't know if you're meaning the temperature or the time, and I assume the temperature.
It's not time. What's that last word say?
I'm not done writing because I keep getting interrupted. Time is continuous. Time is continuous. So anything to do with time, it's continuous.
What's the world like on that?
Well, let's not.
Just,
Yeah, time keeps going. We're just dead.
Did they ever think about that?
Time doesn't stop. We're just dead. All right, the height of a rocket after a launch. Why is that continuous?
Time is continuous.
Look at you go. Take a point, baby. Because time is continuous. Well, you didn't. Are we ready to check our study guide?
No.
You never answered my question.
Wait, we put the back
You're so cool.
You know what, Miss Asbury?
Alright, let's get out our study guide so that we can review it. Study guide, study guide, study guide. Alright, let's look at this, let's look at this. Get ready. And also change your page number in the top right hand corner of this to page 26. Number 1, which one is a function?
B. I got it.
B is in Bravo?
Oh, yes. I got
exactly.
You do not get a point yet. Do you need to leave a point? Number 3, which relation is a function? Ashlyn. A as in apple. Fantastic. Yes. Alright, now on the test, you're going to have some where you have to explain. And the reason is because X does not repeat. Does everybody understand? Avery, do you have a question? Then can you put your hand down?
Yeah.
Okay. Alright, now on the mapping, why is A not a function? Owen.
Oh, because 3 repeats. It goes to 7 and.
Fantastic. Why is C not a function? Jack.
C is not a function because the point is going to -2 and 3 and it can't do that.
Yes. And why is D not a function? Dominic. Fantastic. Turn the page. Everybody take a photo.
Everyone go home.
If only. If only.
I think that I'm lonely. I was like,
No, I'm not. I'm surrounded by people all day long.
I was like,
You can still be lonely on the
I would love to be. Anyway, number 3. Bell. What'd you say? C as in potato? Yes, it is C as in potato.
I was gonna cut my hair. Well, you were right.
Did you just ask what a potato is? No, it's a potato. You've never had a potato?
No. What is a potato?
can I ask Siri?
Siri.
You should make me turn.
Alright, problem 4. I need somebody besides Ravenclaw to answer.
I got it.
Somebody at Hufflepuff, help us out on number 4. Somebody at Hufflepuff, help us out on number 4. Mark is going to save the team and help us out on number 4. Okay, which one is it? Why is it A? And it only hits it once, right? And no. B has that dot, so it would hit twice. Vertical line test. C, it would pass through twice. And D, it has vertical lines, so those are not functions. Yo. I'm sorry? A picture of what? No, baby. You can watch the video on Google Classroom. That's what we're recording right now.
You got the light on.
Don't draw the light.
What? Okay. It's gonna be on there. Like, what's your YouTube?
Blair Asbury.
It's Blair Asbury. That's your YouTube. Are you gonna post it on Google Classroom?
Every day we post it on Google Classroom. Every day.
I watched it.
So you didn't watch the one yesterday that you were supposed to?
No,
That was a
like,
great.
I don't ever watch it. Like, just as to learn. I get it over here. But
You're
yes,
always. I'm so tired of talking to you.
I'm sorry. I just got it.
You got D as in potato?
Yes, ma'am. I got that right.
Tell me one.
What's a potato?
None of the X's repeat. Good. Take a point.
Miss Asbury, what's a potato?
You should know these things. Alright, so number 6, it says write the ordered pairs represented by the newspaper subscription tables. So it would look like these. I'm going to write it. Just chill.
What the heck? That's what I had. I should have got.
Who are you yelling at like that?
Tired.
Does everybody's thingamajigs look like this?
Yeah.
And then you should be able to graph it without me, right?
Yes.
On a piece of graph paper.
I don't have that.
Yo.
Can I
Number 8, it says identify the independent and dependent variables. Sam, independent.
Number of months.
Number of months is the independent. Look at you go. And the dependent, Tyler, the cost. Fantastic. The cost for 1 year, Jack.
Since each month the month goes about 15.25, if you do 12 times 15.25, that is
It's $183.
Do we agree or disagree? Okay. Alright, so you should be able to graph these, or this one, without me, but I'm going to do a mapping of this one. It's gonna look like this. That's in your notes. It's crazy that I give you the instructions on how to do this. What was I thinking? Alright, does everybody's look like this so far?
Yes.
Alright, so 3 is paired with 1 and 3. Yes, if it asks for a mapping, this is what a mapping looks like. 2 goes with -5 and 4.
So it's not a function.
It is not a function. Why is it not a function?
Because 3 goes with 1 and 3.
Because X repeats. Alright, and it says, then determine the domain and range. Your domain is 2, 3. And your range, look at you go.
You're so cool.
Oh my.
For number 11, your domain is -2, -1, 3, and 4. What, baby?
What is discrete?
Watch the video.
Can you just tell me right now?
Watch the
Just a
video.
simple definition, please.
Watch the video.
I'm just trying to study it right now. I kind of got the first part with the X and the shut equation.
And it's the same thing for the range.
Specific points. Thank you.
Alright. Number 12. Alright, alright.
I'm not ready.
Don't care.
Please.
Number 12.
Start it up a little bit.
Number 12. It says describe what is happening in each graph. So we need to tell what's going on with homeboy taking his test. Okay? Tell me.
As the number of questions go up, the time also increases.
Okay, kind of. But I want you to tell me like what's happening specifically. Yes.
The number of questions.
Yes, but I want you to. Okay, so let's talk about.
No, I mean.
That is right, but I really want y'all to tell me what's happening in the graph. So homeboy is he's answering questions, right? So
Increases and it stays the
he
same.
is answering questions, and is he answering questions steadily? Steadily. Okay, then he pauses, right?
It's not a function.
Then he pauses.
It is a function.
It is a function. That has nothing to do with what we're doing, though.
Yeah.
Alright, then he pauses. Then he answers but he answers faster, right? Okay, so then he answers questions faster. Hi, do you need help being quiet? Okay. Then he answers questions faster. Pauses for a long time. And then finishes the test.
100%. All done. Perfect.
Who actually answered it that way?
I
Do you want to
Take a point for your team.
The student at first spent the same amount of time on the questions, but then got stuck on one, then continued, then got stuck again, but longer.
Look at
and
you
then
go.
Wait, Miss Adderfield, what if I said, stop cutting my paper? What if I said,
Logan, put the scissors up. You shouldn't have those out right now.
What if I said it increases and stays constant? You should increase again and constant again.
No, I need you to literally tell me what's happening based on the graph.
So I have to use homeboy.
Yep. You have to say he is answering questions. You have to tell me what he's doing.
Just answer the question.
And then what does he do? And then what does he do again?
So fast.
And then what does he do?
All this run longer.
And then what does he do?
He finishes it.
Look at him go. Homeboy is killing it. And you should be able to do ordered pairs, right? And domain and range. Now, it says describe the domain and range, not list the domain and range. So if it asks you to describe the domain, that's the years. From 2002. Oh, Blair, that's not how you spell from. From 2002 to 2007. And the range is the number of home runs hit. What was that? -1 from your table. Alright, does anybody have any questions on their study guide?
No, but
If you didn't finish it last night, finish it tonight.
Oh wait, I need to.
Review it.
Yeah,
Which one?
it's on the very back.
The very back?
Yeah.
Okay.
Like we all know you're idiots.
So you should be able to graph because that's what we just did, right?
Oh wait. Yeah, but what about
We did. So you can pick any x values. Now number 20, it says to list the domain and range. So the domain is all of the x values from -3 to 4. I'm sorry, -5 to 4. So it would be -5 to 4, and you'd write it like that.
Oh.
And then your range is from -3 to 3, right? So it'd be -3 to 30.
How do you know to connect those?
No, you can watch the video tonight. Pardon?
How do you know it was that?
Between them?
Yeah.
Because you see how all the points are connected? And so the range literally goes from +3 all the way down to -3. It's all of those y values. We have a y value here and here and here. Your domain goes from -5 to 4.
Yeah, I'm gonna try my best.
That's cool. We'll review them some more tomorrow. No, we're reviewing more tomorrow.
Miss Raspberry.
Yes.
Is it, can I change that?
Nope.
No.
Please don't line up at the door. How about we just sit down? Just sit down. Just sit back down in your seats. Logan, come back to your desk and sit down in your seats. Everybody sit down in their seats. Sit down in your seats.
Sit down. Okay. Miss Raspberry, who's your favorite rapping artist?
I don't have a favorite rapping artist.
Who's your favorite artist?
Logan, do I need to come escort you to your seat, or can you find it without me?
I can find it.
Are you sure? Because that's your desk, not your seat. Look at you go, baby.
Look how you drink water.
Hey,
Because it's at the bottom. There's a whole scene on its own.
That's cool. Wait, who's your favorite scene from Little Story?
Depends on what mode I'm in.
Okay, what about the depressing music?
What? It used to be you don't really listen to depressing music.
I listen to X-X.
now wait.
Okay.
Hey, it's still video recording. Well, thank you for today's lesson. And this will be another.